In this problem, we're told that the following graph is a transformation on the function y equals x squared, and we need to write its equation. Notice in the upper right hand corner, I drew a quick sketch of y equals x squared, and note that y equals x squared normally has its vertex at the origin here at 0, 0. So what they must have done to get this graph is take this graph and move it to the right 2 units and then down 1. So to get the graph to go to the right 2 units, you should have learned that that would be obtained by putting a minus 2 inside the function, meaning it's going to be inside the squaring process. So rather than having x squared, you're going to have x minus 2 squared. So that alone, making that change from x squared to the quantity x minus 2 squared, would move this graph to the right 2 units. But notice that the vertex is below the x-axis, so they must have also moved the graph down 1. To shift graphs down 1, you need to subtract 1 on the outside of the function. So if you were to type this equation into MathAS, you would get it wrong, because it turns out they did more than just move the graph to the right 2 and down 1. In fact, down here it says the hint, there's also a vertical stretch or compression, meaning that they may have made the graph skinnier or wider than normal by multiplying on the outside by some number a. Now, not that it's real important, but I know that a must be positive, because if a was negative, putting a minus on the outside would reflect the graph about the x-axis, and then you'd have an upside down parabola. So a should come out to be positive. To find a, what I need to do is plug in a value of x and y, meaning I need to find some other point on the graph besides the vertex and plug in the x and y coordinates. The programmer of this question is really good at making the y-intercept come out nice. So for example, I wouldn't want to pick this point right here because you'd be estimating its coordinates. You know, is that 3.5, comma 3.5? I don't know, you know, so pick a point that lies right on the grid line, like 1, comma 1 would probably work. But I usually just go, probably 3, comma 1 looks like it works as well, but I usually go for the y-intercept. But it's interesting to note that you could actually pick any point on the parabola. I just want to pick one that I'm pretty optimistic that those are the exact coordinates. So I picked the point 0, comma 6, meaning that if x is 0, y must come out to be 6. So I'm going to replace y with 6, and I'm going to replace x with 0, and I'm going to do the arithmetic here. And there's a common mistake I see students make when they do this. So let's do this. 0 subtract 2 is negative 2. When you square negative 2, you get positive 4. What I see students doing, though, is writing it this way. They copy the a, and then particularly if it comes out negative, but in this case it's going to be positive. This is negative 2 squared is 4. What they do is they put plus 4 here for some reason, or actually more common, they write 4, but then they copy the minus 1 here, and then what they want to do after that, what really makes it wrong, is they say that 4 minus 1 is 3. Do not do that. You cannot subtract the 4 minus 1. Multiplication comes before subtraction in mathematics. You need to know that there's multiplication here, and since multiplication becomes first, you cannot subtract the 4 and the 1. In fact, I urge you to write your answer this way. 0 minus 2 is negative 2. Negative 2 quantity squared is positive 4. Put the 4 to the left of the a. That number is being multiplied by a. This is 4 times a all day long, so don't make that mistake. Now when I copy the minus 1, this looks like a typical linear equation that you know how to solve by adding the 1 over. That would make that a 7 over there. And then after adding the 1 over to the other side, you'd be left with 4a over here. Since the 4 is, again, being multiplied, you would solve the equation by dividing by 4. The 4's would simplify out. This is called canceling, but what's really happening is 4 divided by 4 is the number 1, and 1 times a can be written just as a. So I found that the a value is 7/4, which is a number bigger than 1, so what that means is that the new parabola would be skinnier than the old. So if this is y equals x squared, your new parabola, by multiplying by 7/4 would make it skinnier. It would vertically stretch it, in addition to moving it to the right 2 units and down 1. So what you need to type in MathAS is this equation right here, except you need to replace a with 7 force. So to check this, you may want to take your graphing calculator and type in this equation here and see if it looks anything like this. So I'm not sure that I can do that here. I'm not sure I could fit this in given the window that I have, but I could go to my y equals in my calculator, type in parentheses 7 force. I didn't plan on putting this in the video, but we'll try. Let's see here. And then it was parentheses x subtract 2 quantity squared, and then to move it down one you write minus 1. So if I was to hit zoom 6 to graph this in a standard window, I should see that I get a parabola that's moved to the relative to y equals x squared, got moved to the right 2, down 1, and also passes through 0, 6. In fact, if I hit trace, the default on the calculator is to start at x equals 0, and notice that it goes through 0, 6, just like this one. So it's interesting to note that if I would not have put the 7 force in here, without the 7 force, what you'd have gotten is a parabola that got shifted to the right 2 and down 1 like normal, but notice it would go through 0, 3 rather than 0, 6. So that shifting factor of 7 force was necessary to get the parabola to be skinnier, so that it would go through 0, 6 rather than 0, 3.